This is a very basic question and a very conceptual question of rotation motion. This wheel is undergoing pure rolling. So V is equal to omega r. We need to find out which points among these A, B and C has maximum speed. So for finding out that, we first realize that this object is doing combined rotation and translation motion. So the velocity of any point on a object doing such a motion can be found out by first visualizing it as rotation about center of mass and then adding the translation factor of center of mass onto the point. This is the standard thing you do in any question of combined rotation and translation. There is an easy way for this question which I will tell you later. This is a point A. Now when we visualize the rotation about center of mass, which is this point, it is omega into this distance on this side, and then we add V, that is the velocity of center of mass, to this point again. So the actual velocity of this point will be the combined resultant vector of these two vectors. Now for point B, it will be omega into this distance L2 perpendicular to this region, omega L2, and then we add V again in the horizontal direction, and the resultant velocity of this point will be the summation of these two velocities. Now from these diagrams, it is very difficult to find out the magnitude of which velocity vector will be the greatest. So we have to look for another method to find out the speed of which point will be largest. So in questions of pure rolling, mind you, always remember that when you check the lowermost point, this is a wheel, let us check what is the velocity of this lowermost point. For this lowermost point, when we visualize the rotation motion about center of mass, we find the velocity of this point to be omega r on this side. Now when we add the translation factor of center of mass, we will add V to this point. Now we know that V is equal to omega r. Therefore these two vectors cancel. So what we know is that in case of pure rolling, the lowermost point is always at rest. This is an important thing which you will realize, and you may feel awkward for the first time, that when your car runs and if it is not slipping on the road, then the lowermost point of the tire is always has speed 0. But despite that, the car is moving. So whenever you apply equations in rotation motion, whatever equation, torque is equal to I alpha, or whichever equations you want to apply, you can either apply it about center of mass or about a point whose acceleration is 0. Now in this case, if we visualize this point is at speed equal to 0, its velocity is 0. Now this whole object appears to rotate about this point at this instant of time. At this instant of time, I'll repeat it again. At this instant of time, since this point is at speed 0, this whole object seems to rotate about this point with angular velocity omega. You also keep this point in mind that the angular velocity of the object when the rotation is seen about any of the points of the object is always the same. So if you know the angular velocity about center of mass, you also know the angular velocity of the object about this point. So the angular velocity of the object about this point is omega, and since this point is stationary, there is no translation factor attached to it. So at this instant of time, the object's whole motion is only rotation motion. Now in only rotation motion, we all know that the velocity of any point will be omega into the distance of that point in a perpendicular direction to the radial vector. This whole object is doing rotation motion, pure rotation motion about this point. So the velocity of this point was omega r1. The velocity of this point will be perpendicular to the radius vector of that point with respect to this point into omega r2. So basically what we come to know is that the magnitude will depend on the distance of that point from the lowermost point. So in this question, the distance of A from lowermost point is this, so its velocity will be something like this. The distance of B is this, so it will be multiplied, omega multiplied by this distance, so it is something like this, and the C being the farthest will have a velocity like this. So the velocity vector of C will be the greatest, and therefore C will be having the maximum speed. So we can directly say that VC is greater than VB is greater than VA. This is an important concept which can be utilized in many other questions. Just remember one more thing, in future questions, whenever you see pure rolling, rather than applying the equation of torque is equal to I alpha about the center of mass, you can also apply the equation of torque is equal to I alpha about the lowermost point. It actually simplifies many of the questions. Remember this trick, and the answer for this question is VC is the point C has the highest speed.